MgcSTEM PWM 2.0a. Mode B, Battery Adapter Upgrade Solution. Hello everyone, today we'll create a video tutorial on the wiring connections for upgrading power wheels using the PWM 2.0a module in Mode B, combined with a 3-pin resettable pedal switch, a 6-pin shifter, and a multifunctional battery adapter. After upgrading with this solution, you can directly use 18V/20V DeWalt tool batteries to enhance the vehicle's power and speed, while achieving soft start, braking, 3 gears, forward, stop, reverse, and retaining the original 12V system features such as lights, horn, and Bluetooth. The soft start function protects the gears in the transmission, and the battery adapter's low-voltage protection prevents damage from over-discharging. The physical connection method uses a multi-functional battery adapter as the power source, with 2 separate output lines. 1. Motor power circuit. Battery voltage supply. The battery voltage flows through the fuse, pedal switch, PWM module, and shifter to the motor. Note: for dual motors, connect them in parallel. To ensure both wheels rotate in the same direction, cross-connect the terminals. Connect the positive terminal of one motor to the negative terminal of the other, and vice versa. 2. 12V voltage circuit. Dedicated to powering lighting, audio, and Bluetooth. Note: connect the 12V output directly to the original vehicle's battery wires and remove the original battery. This 12V line supports a maximum current of 2.5A. Let's look at the circuit diagram. I'll explain it in the order of current flow from the battery to the load. First circuit, battery voltage to motor. Power circuit. The battery's B+ terminal connects to the fuse. The fuse connects to the brake pedal. Brake principle. When the pedal is not pressed, pins 2 and 3 of the pedal are disconnected, while pins 1 and 2 are connected. This cuts off the battery's connection to the PWM module, stopping its output. Additionally, since the PWM module's P+ and M+ terminals are internally connected, releasing the pedal while the vehicle is moving shorts the motor to generate reverse braking force, achieving a braking effect. When the pedal is pressed, pins 1 and 2 disconnect, and pins 2 and 3 connect. Current then flows through pin 2 to the PWM module's P+ terminal. After modulation by the PWM module, current flows from the PWM's M+ terminal to the shifter, then through the shifter to the motor's M+ terminal. Finally, current returns from the motor's M terminal through the shifter to the PWM's M terminal. After modulation, current flows from the PWM's P terminal through the main switch to the adapter's G terminal, then to the battery's negative terminal to form a closed loop. Second circuit, original vehicle's 12V voltage circuit. Connect the 12V output terminal to the original vehicle's positive battery wire. Connect the original vehicle's negative battery wire to the main switch or PWM's P terminal. Current flows through the switch back to the adapter's G terminal to form a closed loop. Skip this step if using an adapter without 12V function or if 12V is not needed. This replaces the original battery with 12V from the adapter. Remember to remove the original battery, allowing the original 12V components to work normally. Note: the adapter's internal 12V DC-DC supports a maximum current of 2.5A, which is generally sufficient for original 12V components with some margin. If adding extra 12V devices, e.g., additional lights, calculate the total power to avoid exceeding this limit. Overloading will trigger overcurrent protection or a short circuit, causing a full power cutoff. The entire wiring must follow this diagram's order. Flip the PWM switch to the outer side. Position 1 as per the manual. Adjust the potentiometer knob to set the total output power. Turn clockwise to maximum for higher top speed. After these steps, insert the battery into the adapter to activate the module. Set the battery adapter parameters. Default settings usually work, and the system is ready for use. Advantages of this upgrade compared to the original setup. 1. Upgrading from 12V to 20V significantly boosts the vehicle's power. 2. The 3-second soft start reduces startup impact, protecting transmission gears and improving driving safety and comfort. 3. Integrated braking. Simply release the pedal to stop, enhancing safety for children. 4. The multifunctional battery adapter provides programmable low-voltage protection, preventing costly battery damage from overdischarging. And a 12V output for original lights/horn, eliminating the need for separate upgrades, making it a cost-effective, high-performance solution. Note, the PWM 2.0 has resettable overcurrent protection. If peak current exceeds 35 A or continuous current exceeds 20 A, protection activates to limit output, lowering power, and maintain 20 A continuous current. It automatically resumes normal operation once current drops, with no need to replace fuses. For Mode B of the PWM 2.0A, I'll explain the brake pedal installation in detail. In this mode, the PWM module's output depends on whether the pedal is pressed to supply power. Thus, the wiring must ensure. Pressing the pedal connects the battery to the PWM module, enabling output and motor operation. Releasing the pedal cuts off the battery PWM connection, stopping output and shorting the motor to generate reverse braking force. Pressing the pedal again restores power to the PWM module, restarting it. The shifter connection is slightly more complex. To avoid errors, a detailed explanation is provided later in the playlist.